Hi everyone. Today we are going to continue with our little mini series in Unit 10, if you will, mini series, about transformations. So yesterday we looked at translations. That was where we took a shape and we slid it in one direction. Maybe we slid it down into the left or up into the left, but we slid it in some direction. Today we are not going to do a bell ringer, but we are going to look at symmetry. Now, symmetry, I love. It's probably my favorite. It's because it's something that can be seen all around us. It can be seen in nature. Um, it can be seen in buildings and whatnot. But a line of symmetry is a line that can be drawn through an image that divides it into two equal mirror images. So we've got Batman. And so I could draw a line through here. And if I were to take this side over here and fold this in half, these two images would line up. They would make a mirror image of one another. Now, I could not draw it this way, because if you took out the symbol inside, that would be a mirror image, but because the symbol is in there, then really what would happen is that this would come around like this, and then it would go like this, and then like that. And so it wouldn't truly make a mirror image. So this one has one line of symmetry drawn vertically. For this one over here, this one's a little different, so it looks kind of cool. So let me see what happens if I draw a line through it. So I have to be careful. If I look at the outside, if I look at the red, it seems like, yeah, this would overlap. But if I look at the purple, does it overlap? So this is going here, so that means that it would have to go like this. So the purple actually makes this so that it's not a true, there's not a true line of symmetry. Now I could check that in a bunch of different ways, or in a bunch of different directions. But this one, even though we have to be careful, some are going to be really tricky and we're going to look at them and go, yep, that looks symmetrical. But really, this is going to be a better example of rotation, which we'll look at next time. So reflection is a transformation that flips a figure over a line. So if I have a line like this and I've got a shape that looks like this, it's saying, okay, a translation is sliding it across. But a reflection is picking it up and flipping it like a mirror image. A line of reflection is this right here. It's the line that a figure is flipped or reflected over. So the action of flipping this across the line is called a reflection, but the line of reflection is the actual line that it's flipped or reflected over. Graph point F41. Okay, so let's start with that. So I'm going to go over 4, up 1, and I'm going to label that F. And then it says to graph its reflection over the x-axis. So let's start with that. So if I look at the x-axis, that's my line of reflection. I'm going across here and saying, okay, I'm not moving it to the left or the right. I'm just flipping it over. So it's 1 away from the x-axis right now. So I need to move 1 away in the opposite direction. And it would go right here. And this would become, oh no, this would become F prime. Because I did a transformation. Of course, the directions also say to graph the reflection across the y-axis. So now I'm looking at this direction. So I'm going to look at, okay, how far away is it from that line of reflection? It's 4 away. So I need to move 4 in the opposite direction and put the point there. This was F prime. I'm going to go ahead and call this F prime as well. I know that they're not the same point, but it's just showing that this was the pre-image, this is the image, and this is an image. They're both what happens when we reflect the point. So then if I had the point C is -1, 2, if I reflect it across the x-axis, that's this point here. So I'm going to say, okay, how far away from the line of reflection is it? 2 away. So I need to move 2 in the opposite direction. And that's going to go right here. And I'm going to call that C prime. All right. Now let's do that one. I have to reflect it across the y-axis. This is 1 away from the the y-axis, excuse me. And so it also has to be 1 away this direction. So this is going to be C prime. I didn't actually label that C, and I should have. Both of these would be reflections. You just have to read the directions carefully of which line are we flipping over. All right, try this point, pause the video, and then come back and check your work. All right, so yours should look something like this. Sorry, it's all in one color. I can't change my pen color when I'm not recording. So I'll just trace over real quick. Okay, so what I did was say, okay, I graphed my point of H at 6, 4. And then I said, okay, for the x-axis, how far away is H from the x-axis? It's 4 away, so I need to move 4 in the opposite direction from the x-axis. When I say opposite direction, I'm talking about the opposite direction in the x-axis. So if I start here at the x-axis, to get to 4, I have to go up, or sorry, to get to H, I have to go up 4. So to get to H prime, I would go down 4. If you want to think about it another way, you could say, okay, I'm going to move from H to the line of reflection 4 units, and then I'm going to keep moving in that same direction 4 units. But I think it's better to think about how far away is it from that line of reflection, and then move that far. With the y-axis, I can see here's my y-axis, and then I'm 6 away, so I need to move 6 away. All right. Let's make it complicateder. We've got triangle ABC is at the given points, -4, 3. So -4, 3, that's A. B is -1, 4. And C is -3, 1. All right. Graph the reflection across the y-axis, and then use arrow notation to describe the original triangle and its reflection. All right, so I'm going to use purple to show my image. If I'm reflecting across the y-axis, that's right here. And what I'm going to do is reflect each point of the triangle across the y-axis. So I'm going to look at B first because it's the closest. It doesn't matter what order we go in. It is 1 unit away from the y-axis, so I'm going to move 1 away for the image. So it's going to be B prime. A is, I'll just keep it in purple. A is 4 away, so I'm going to move 4 in the opposite direction. So that's A prime. And then C is 3 away, so I need to move 3 in this direction. And that would give me C prime. And then I can connect those dots. And what should happen is if I could pick this graph up off of the paper or off the screen and fold it in half along this line right here, the y-axis, those two triangles should overlap. So we did the first part. It said graph the reflection. All right, we're done with that part. But then it says to use arrow notation. So just like yesterday, what we're going to do with arrow notation is start with x, y, because we're saying A, B, and C started off as ordered pairs x, y. This was x, this was y, this was x, this is y, etc. Now, what we need to do is look at what is the rule. What happened to get from B at -1, 4 to B prime? Well, the coordinates of B prime are 1, 4. So if I look at -1, oops, sorry. If I look at -1, 4 and 1, 4, what do I notice? The y stayed the same. The only thing that changed in the x is that it's a -1 now, so I multiplied by -1. Okay, let me check this for something else and see if this works. Let's check with A. A was at -4, 3. A prime is at 4, 3. Did that rule hold? Y stayed the same. And for x, I just have to multiply by -1. Hey, that makes sense. So here's what my rule is going to be. I'm going to put -x, comma, y. And so the arrow notation is saying when you apply this translation, or this reflection, we are going to take -1 times x And we don't write the 1. Remember, we don't write it 1x, we just write x. So negative 1x, comma, y. So this would be our arrow notation. All right, try this one, see what you get, and then check your work. Okay, so if you graphed your triangle, hopefully you saw that it was the same triangle from last time. It's just that this time we're reflecting across the x-axis. So if I were to draw a line through the x-axis and then fold that in half that direction, then this triangle here, triangle ABC, would overlap with triangle A prime, B prime, C prime. So the only thing left to do is the arrow notation. And to do arrow notation, I'm going to say, all right, I started with my ordered pair of x, y. And then to transform it, what happened to the points, like to get from C to C prime? Well, C was at -3, 1. C prime is at -3, -1. What do you notice? X stayed the same this time, and y multiplied by -1. Let's check with B. We've got -1, 4 for the original, and then the image is at -1, -4. Those are the same. These multiply by -1. So our rule is that our x stays the same, it just stays x, and then our y is the one that's going to be multiplied by -1 this time. So that was not your homework, but when you're writing these rules, think about it's always going to be multiplying either x or y by -1, but you'll just have to think and check and see which one is it. It's a reaction, I think, of a lot of people to say, oh, we're reflecting across the x-axis, so x is times -1, but that's not the case. Notice that here and here, the one that stayed the same was actually the variable of the axis that we were reflecting across. Here we reflected across the y-axis and y stayed the same. Here we reflected across the x-axis and x stayed the same. So just take your time, pay attention, and let me know if you have any questions.